Good everyone, my name is Graphics. If you look at the front of the screen, you will see a question that is involving a concurrent coplanar force. But this question is not like the other question we've solved so far in this tutorial. This particular question have unknown. We are told that we should find the tensile force in the cable AB and what BC, right? Because without that we cannot calculate for the resultant force. So we need to know what force is acting along AB and what force is acting along what BC. So the first thing you first of all do, you have to draw the free body diagram of this figure, and when we draw it, this is what we are going to be having. Now this is what we have here. We are told to look for the tensile force. So we're going to call this point here, we'll call it F, that is T if possible, tensile force. We call it F AB, that is the tensile force along member AB, and we'll call here also, we'll call it FBC, the tensile force along what? Member what? BC. Then this point here is giving us what? 200 Newton. That's for the pulley, the weight of the pulley at that point. Now the force of the pulley here is giving us what? Another 200 what? Newton, right? Now this is what we have. Now in doing it this way, we will now start. Now there are three conditions necessary for equilibrium. Is that taken? Now the first condition is saying that what? The summation this way, the summation of f of x is equals to what? 0, right? That is the first condition. Summation of what? F of x is equals to what? 0. Now we are going to consider, f of x means horizontal component or forces acting along x-axis. So we are going to consider any force that is facing forward to be what? Positive, and any force that is facing backward to be what? Negative, right? Now before we can input it, the first force we have here that is horizontal is what? 200, and it is facing forward. So the first thing I'll be writing is what? 200 what? 200, positive 200. Now if you look at it, it looks like there's no any other horizontal force, but there is, because we need to resolve each of these inclined forces. Now I said something earlier that if I want to resolve this, at this point here, if you put your 4 cardinal point at this point here, let's just assume this, right? Let's just say here is the north, here is the south, this is what? The east, and here is what? The west. You can see that. Now what I'll do is, this inclined force is in between the north and the east, so I'm going to bring out the north and the east out this way. Is that taken? Now since the force is inclined to the horizontal, this is the horizontal here along x-axis, you say that this will be the cos of the angle, which is what? 30 degree, right? And this will be, if this is the cos, here will now automatically be the sine of the angle, which is what? 30 degree. Now the force that is acting at an angle of that will now be what? FBC. So we'll now be having FBC sine 30 and what? FBC cos 30. The arrow is going outward, so this arrow will be going outward this way. So what I just did here, we call it the resolution of what? Of force. So I have resolved this inclined force into vertical and what horizontal component, right? So if you want to know more about this, you can just click on this link at the top right corner here. It will take you to where you see more explanation on this. Now this is another horizontal component along x-axis and it's facing forward. So I'm going to put plus FBC cos 30. Is that taken? Now the next one is another inclined force again. I'm going to resolve. No, this is now north and what? West, right? And this force is falling between north and west. So I'm going to bring out the north and west. So this is north and this is what? West. Is that taken? The arrow is going outward. So I'm going to say this arrow is going outward. Now, since the angle is inclined on the horizontal, this force is inclined on the horizontal, we'll be having cos of the angle, which is what? 45 on the horizontal, and we're having sine of the angle, which is what? 45 in the vertical. Now, what is the force that's inclining? That is FAB. So I'll put the FAB multiplying this, and I'll put the FAB multiplying this. Is that okay now? Now we have another horizontal component which is facing backward. And as any force going backward is what? Negative. So I'm going to be having minus what? FAB, right? Cos 45. Right? Now the next one is, this also is inclining. Now this inclined force at 60 degrees is in between west and south. Right? So I'm going to bring out this represent the west, right? And this represent what? The south. And the arrow is going outward. So I'm going to assume the arrow going what? Going outward this way. You can see that? Now if I do that, since it is inclined to the horizontal, means that horizontal will be cos of the angle. Cos of what? The angle. What is the angle? 60 degrees. Then this will be the sine of the angle, and the angle is what? 60 degrees. So what force is inclined at that angle? 200 Newton. This will be 200 sine 60 and 200 cos 60. Now this is another horizontal force parallel to the x-axis. So and it's facing backwards, so it will be minus what? 200 cos 60. Is that taken? Equals to what? Equals to 0. Now if I resolve this, right, we say that my 200 from here, the 200 that we have here, plus cos 30 is giving us 0.866. 0.866 multiplied by the FBC, right, minus cos 45 is giving us what? 0.7071 multiplied by the FAB is what we have, minus 200 cos 60 is giving us 100. So we're having minus 100. This is what we have here. Now this will now be equals to what? Equals to 0. Now if you rewrite this, we're going to be having 0.866 FBC, right, minus 0.7071 FAB. Then 200 minus 100 will give us 100. So we have plus what? 100. And this will be giving us what? 0. Now take this 100 to the other side. So I'm going to be having 0.866 FBC minus 0.7071 FAB equals to what? Minus 100. So I'll call this equation what? Equation 1. Right? So this is when you are considering the forces acting along x-axis. That is the first condition for equilibrium. Now the second condition for equilibrium is, we're going to say that the summation of f of y is equals to what? 0. Now I am going to consider the forces acting upward to be positive and the forces acting downward to be what? Negative. You can see that. Now when you move forward, let's see. So when you move forward, let's see all the forces we have facing upward. Now we are only considering all the forces that are standing in. So this one, since we've resolved, we don't have business with all the inclined force. We only focus on this resolved force. So this is facing upward and it's positive. So we're going to be having F, right, BC sine 30, right. The next one is, this is also facing upward, FAB sine 45, positive, FAB sine 45, right. Now if you look at this, this is facing downward and that will give us minus 200 sine 60 equals to what? 0, right. Now when we continue from here, from this point here, now I take this up from this point, sine 30 is 0 point what? 0 0.5. Let's move forward. So sine 30 is 0 0.5, so 0 0.5 this way times FBC, that again, plus sine 45 is 0 0.7071 times FAB minus, we have 200 sine 60 is going to give us what? That will be 173.2, right. So we have 173.2, that will give us 200 sine what? Sine, so write it, 173 point what? 21. That will have equals to what? 0. So if we move forward, then we're going to be having, take this to the other side, so this will be 0 0.5 FBC, right, plus 0 0.7071 FAB equals to, this will come to the other side, will come positive, 173.2, right. I'll call it equation what? Equation 2. Is that taken? Now the next thing is, I can just say 173.21, yes. So we've gotten equation 1 and what? And equation 2. So what we are going to simply do here is that we are going to combine, let me take it here, we're going to combine equation 1 and equation 2. So I'm going to write it, combining equation what? 1 and 2. So when you combine equation 1 and 2, we're going to be having this. So let's put that here. From here, we're going to be having, we have this equation 1, which will give us 0 0.866 FBC minus 0 0.7071 FAB equals to what? Minus 100. And the next one will now be, that's my equation 1. Then the next one is 0 0.5 FBC plus 0 0.7071 FAB is equals to 173.21. That is my equation 2, right? So let me take this down this way, so we'll see what we're actually working with. And when you do that, we're going to solve them simultaneously. Now the good news here is that FAB have the same value, and one of them is negative and the other is what? Positive. So that means I'm going to add equation 1 and what? Equation 2. So in adding equation 1 and equation 2, right? In adding equation 1 and equation 2, it means when I have my 0.866 plus 0.5, I'm going to be having 1.366 FBC, right? 1.366 FBC plus, now if you look at this, plus this minus this is all giving us 0 because this will equate this, right? Equals to minus 100 plus 17321 will give us 73, right? 0.21, right? So we have this. Now if you do this, whatever you add with 0 will give you that same value, right? So whatever you add with what? With 0 will give you that same value. That is why we're having this. Now divide both sides by 1366. I'll be having FBC should now be equals to what? 73.21 divided by what? 1.366, right? So my answer will now give me 53.59 Newton. 53.59 Newton, right? So that is what we are having as our FBC. Now the next thing is you are now going to input your FBC into equation 1. So I'll write it this way, that substituting FBC equals to 53.59 into what? Into equation 1, right? If I do that into equation 1, I'm going to be having so let's start this equation 1 here. So I'm going to be having 0.866. Instead of me writing FBC, I'm going to put 53.59, right? Now minus 0.7071, right? FAB equals to what? Minus 100. Now when you multiply 0.866 times 53.59, you're going to be having 49, that is 46.409, right? Minus 0.7071 FAB equals to what? Minus 100. Now if you collect like terms from here, you're going to be having minus 0.7071 FAB will now be giving me minus 100. When this is coming to this side, it will become minus 46.409. That will now become minus there. So from here, we are going to be having minus 0.7071 FAB will now be equals to minus 146.409. What we have here, right? So move forward. So from here, if you divide both sides, you discover that you divide both sides by minus 0.7071, the FAB will now be equals to minus 146.409, all divided by minus 0.7071. So this will equate this. Now when you now divide both sides, divide 146.409 by 0.7071, my FAB here will now be equals to we have 207 point what, 0.05 Newton. So this is what we have. So we've gotten my FAB and we've gotten what, my FBC. So this is the tensile force. So the tensile force acting at this point here, let's move. So the tensile force acting at this point here, AB, right, is given as what, 207.05, and the tensile force acting at what, BC, is given as what, we have 53.59 Newton. Like, it's easier for you to be able to calculate for what, for the resultant force, right? So it is easier since we've gotten the value of what, the resultant force. What you just have to do, if you are told to calculate for the resultant force, just impute the value of FAB and FBC into this equation here, so you get a total value. That value you get will be your summation of f of x, and you do the same thing for summation of f of y, and you input the value of FBC and what, you put the value of what, FBC here and FAB in equation 2, you get the total value of what, summation f of y. Now we know very well that what, the resultant force, R is equals to what, the square root of the summation of fx all square plus what, the summation of fy all square. So when you input your value into this equation, you're going to get the resultant force of this system, right? And if you don't really understand what I'm trying to tell you, just click on this link. It will lead you to a place whereby you will learn how to resolve forces, that is under concurrent and what, coplanar force. So if you have found this video helpful, please don't forget to click on the subscribe button. Thanks for watching.